the Soho or similar, or Indian Railways also through Vande Bharat. I mean, world class have been still a dream for many. So I think many of the questions I have received from some of you also indicate about certain areas of interest in research, certain aspects of software engineering which are changing, and how it makes sense for the current world as an opportunity as well as a landscape. So I think I will, I mean, this is obviously some of our journeys which are captured here over the period of maybe 2 decades or more, which we have spent in the industry. We have tried to dream about world class, and some of the products we have been fortunate to make from India, which are world class. So that it's also a combination of what we know as well as what is happening in the industry. So I will basically be going through the significance of software testing, or the testing aspect of it, and how it becomes more important when speed is something that is pervasive, becoming more important in today's market, and how the landscape is emerging with some examples. And I will basically end with a certain set of demos. Yeah. Just to kickstart this discussion, I flicked some picture that HR Mohan sir has shared in LinkedIn, and this keeps us thinking. So here we have this automobile. Don't know what kind of automobile exactly it is or what type it is. Kind of carrying a lot of people, carrying a lot of vessels and a lot of vehicles. So I think this kind of shows parts of the developing world trying to cope up with what is there and what we can do with what is available. So I would like to, with this kind of pose this quick question to many of you, to ask this question about how many of you do you think operating much beyond expected load is an opportunity? So maybe you can just put it on the chat window, just share your yes or no's, so that I can get a feel of what you think about such a, whether you see it as an opportunity to overload our systems. So maybe, yeah, I mean, you can answer with your yes or no's, so just to get your opinions and thoughts about it. Okay. Thank you, sir. Yeah, this any of I mean the participants, please feel free to comment. Great, thank you. I think it's going on. Yeah, please feel free to comment. I just thought we should get some feeling of what each of us think as opinions. Yeah, I think we got some inputs. Thanks a lot for your inputs. I think we'll move forward. Several people who are concerned about reliability, I see, has expressed no very clearly. We have a lot of yes as well. So I think, leaving out the system side, probably, I think we are looking at it as an opportunity today. And again, one side, it doesn't mean we should leave out the tests. That's also an important point that we have to make here. It doesn't mean we are making our tests only limited. Instead, rather we try to, because of the application needs, often we kind of test it more. So one of the major, say, 3-ton truck product makers in India, in one of the product conferences, they had clearly pointed out the fact that they just don't test it for the 3 tons that is expected load. They rather test it for 10 tons, because many of the applications in the villages, or many of the applications in Indian countryside or in the developing world, is more probably having an overload. So this is the kind of interesting paradigm. Probably we might have to. That means to say we are going to be overloaded. That's the kind of scenario that we have. And again, especially with software, uh, since it will evolve over time and it can sustain if the load is contained, this is a much more bigger possibility. So we are hearing a lot of such terms like do more with less, get it right first time. But it often poses a question to us: how do we really do it? How do we really get it right first time? And how do we really do more with less? These terms, I think we are trying to look at this. In this session, we try to look at how we can still do a good job with what we have, and how we should look at our ecosystems, and how we should manage the speed aspects to deliver quality. So that's the kind of thinking that we pose here. Obviously, this picture might not be the right thing to do, but it indicates to us some kind of considerations to make. And even here I pose this question to pose this point to all of us. Obviously, without some kind of testing and some kind of robustness, it would not have carried all these. So, but quality is never an accident, like Mohan sir was pointing out, and that is what we are kind of trying to delve deeper into software aspect of it and go ahead. So just to look at it from both sides of the story, the executives are looking at making systems that scale. I want to add 1,000 users. From 1,000 users, I want to move to 5,000, and then 10,000, and then I want to make it 100,000, and I want to make more money out of what software I have built. This is the kind of thinking that is going around, particularly in the cloud world. This makes some sense, but again, there is a balance to make here. And how can we get to market faster? That's another sort of the story. At the same time, we want to get to market faster. And so here, in between these two, and the other set of people who are thinking about how do we really make sure we are ensuring the quality. So that's the kind of consideration that we are into. So because fundamentally our executives are looking at faster timelines or speed, churning out, and how to getting it to market faster. And maybe also once you are in market, you have to scale like anything. So this, and then again, in the ecosystem, you have dependencies, like several software is having dependent software. And then if that evolves, how do we manage that? So within this kind of constraints that we work with, we have to ensure the quality. And why we should really ensure the quality? It is nothing but the failures that we have been through, which indicate very clearly that the scapegoat has been quality and testing. So examples include Ariane 5, which is from the aerospace aspect. Another is Galactica. Another is an income tax portal. Many of us would be more used to for doing the e-filing. And on the other side, you have autonomous cars like Tesla. So this Ariane 5, it happened in 1996. The failure caused complete loss of guidance and attitude or information 30 seconds after liftoff. It's altitude information. So it was thoroughly reviewed, because many of the aerospace aspects are thoroughly reviewed, and then it came out that the reviews and tests did not include adequate analysis and testing of the system. So that is a kind of simple. It's a non-fact. How much should we cover? How much of time we have to spend on verifying some of these, and what are the kind of review methods that we are applying? Even with all that, the failures happen. And you see on the other side, Galactica, which was this was released by the Facebook guys, based on Meta guys, basically based on the existing GPT-3 approaches, and then it was able to. It was the purpose was like it can create a new research paper like a human does. So that was a kind of a demonstrator they had. But people started verifying it in different dimensions, and within no time they had to stop making it generate. So you see the generate button changed to paper, so they had to recall. So the point here is it was within a week they had to recall. So that means it was not verified enough to the extent it was required. So, but then many big companies are going to do these kind of experiments to get the feel of things in and around. But you see, the point is, if it is not verified enough, it's going to fail. So it's like it's not an accident that the failure happened. It's a very non-fact. And we also see in the Tesla case, even still with autonomous cars, a lot of incidents are getting reported, a lot of analysis happening, and still, it's improving over time. So from one end to the other, we see several scenarios of failure. And together with this, we have other challenges like we are talking about digital transformation, Industry 4.0 and things like that. And that's where it becomes more and more difficult to see, have a look at clarity in testing or the adequacy of testing and what we really need to do. And most of the time we know this point that the later in the development cycle an error is found, the more expensive it is to fix. Yet we don't seem to care. So this is the most important challenge which we are seeing, and how to navigate through this speed is what we are also kind of discussing. Just quickly stepping back, looking at quality. So I have here a picture of Vishwanathan Anand, chess champion from India, representing. So he represents a class like world class from India. And the difference between not world class and world class is all about a seal of quality. And this quality, when we are talking about, it's much beyond performance scenarios like availability or reliability. It goes towards in the direction of trust. So this is the kind of thinking that we are looking forward. We are moving in the direction of trustable systems. We are looking at quality, the seal of quality when we are talking world class. And this is there is no equivalent to the factors of availability. It is much beyond availability and reliability. So that means to say we have to really achieve the required availability and reliability goals, and then pursue more of human factors of trust. So that is the kind of thinking. Here I would like to also narrate a short person.
Okay.
Personal
okay, no problem.
Story here. I'd like to make here is I was asked to lead this particular product platform architecture in ABB. And I was kind of going to build this from the scratch. Even though there were few experiences behind that, that learning curve, but it was basically thinking from scratch. So, and in this scenario, I was joined with me was this particular manager who had joined recently in a short while. So I was discussing with him about building this team and the culture around it, and how we should possibly select the team members and thinking around all that. I also mentioned about test strategy and the testing concept behind it. In fact, the manager started thinking I am trying to step on somebody else's toes, and so he was kind of pointing to me. You probably look more focused. You look at the architecture aspect. We have a lot of testing people over here who will, or the test managers over here who will take care of the testing aspect. I think I was a little taken back, but obviously I really realized possibly what I was seeing, he probably is yet to see, because I had been in ABB for over 15 years. I had the privilege of being in the verification and validation centers of the organization, and being with IEEE and CSI and all those seniors. I have also seen a lot of how the world tests and verifies and validates everything, mostly aligned to the specification or to align with the stakeholders. So this was elaborately done, and that kind of quest of finding the issues and making your customer experience comfortable and providing the trust factor to the customer makes a world-class organization. So that's I think the point here I would like to make. And then, in fact, even though taken a step back, step back, but I could pursue the concept of testing in the platform still with my some of my colleagues who were new to it and who really wanted to pursue such an objective, and who also believed in the quality as a mindset. So it's this one word that differentiates world-class quality, and then it is like what we see. It is not just a keyword and not handled at 50,000 feet. It is instead something very rigidly pointed out with respect to availability, reliability, trust, and the specification and acceptance of stakeholders. So today it is becoming more and more significant with the customer acceptance aspect, and we will see how we are going to deal with it. Building quality into the workplace is the only way we have to go forward. So it should be part and parcel of everything that we do. And I think that is what kind of ISRO and similar organizations depict to us, the world-class organizations, ABB, Toyota, all those participate, and that is primarily the most important part. And they start from the very early phase of the architecture and design. It's not from the requirements and even the needs. So that's kind of perspective of a mindset of quality that we really want. And in that is where testing would play a role. In fact, maybe what I just mentioned was a little more closer to some of us. So I thought, let us bring it more closest to most of us who are participating here across domains. So one case here, we can say we are in an autonomous car, or we are a pedestrian passing around an autonomous car. And then how we think about quality. So we have at that moment, we will start thinking that, oh, it is really important for me as a mindset. And I mean, if I am inside the car, obviously it should be dependable. Same thing with the pedestrian. It should be predictable if the pedestrian is walking around and the car takes an action. So that being, when we are talking about dependability, it's about trust, which is a very high level of beyond availability, reliability angles. It is about human values and the trust that we are building into it, the confidence for the user that we are building into it. I think when we are talking about financial organizations, we will see similar cases are now emerging more and more. UPI, Unified Payment Interface, talks about if it's mentioned that it crossed 6.7 billion transactions in August. And imagine if our transactions fail, we get frustrated. But maybe after some time, we might again retry. So that kind of tolerance level is there with some of these systems. But when we go to FASTag, it can lead to roads going standstill. So it is probably not allowed to fail that often. So this kind of varies across each of these domains. There is some tolerance level, but fundamentally, we are moving towards more closely watching the functionality as well as performance aspect. Cybersecurity becoming pervasive, and then reliability is increasingly important. When we look at the increasing significance, I thought this is important for us to understand the significance of software emerging as a major component in most systems today. This is an example from Agni 1, Modeling and Simulation, which is mentioned by Guru Kalam in his book, Advantage India. It was because of the MCTR regime. The internal test planned in Germany didn't happen. So it was asked, and also Deshpande at IAC formulated it as a CFD, computational fluid dynamics problem. And at that time, nobody had done hypersonic flight simulation in India. So they used the Prithvi flight data to kind of help with that and kind of validate the CFD model. And then Agni's successful launch happened in 22nd May 1989. First of its kind, tested without internals. So maybe I'm not talking about tested without, rather it might be at a different level that it's been. But then the point is, these are the kind of scenarios that are emerging. The tests are simulation. Modeling is primarily emerging as a big player. And the same, if you look at digital twin models, where we are talking about information to compensate for time, energy, and material, we are probably kind of looking at much more capabilities with software. So that's where software today forms the backbone of our systems, and that's where the discussion of software quality is much more significant. So now, since we have reached software quality, it's more closer to the software angle of things, but you cannot make it independent because software runs on certain hardware. So obviously integration plays a role. But when we look at software quality, it is about two aspects of software quality that we are talking about. One is the errors, bugs, and vulnerabilities. And the other hand, it is technical debt, like you have problems with reliability. That's failure is happening quite often. We have, maintainability problems. It is not maintainable. There is the code is difficult to handle. Its modifiability is also in trouble. Security challenges, like there are vulnerabilities which are leading to problems. So when we are talking about software free of errors, we are talking about making sure logically it is working perfect, its specifications are met, and then it doesn't open up any big challenges. Whereas technical debt, we are talking more from a friction perspective. We are talking about, can this system evolve? Can this sustain? Can we really, how is the user experience going to be? So today, that's where the software quality angle, this is from IEEE Software Magazine, that we are talking about. It's more not just detection, it is more focusing on detection, identification, and recovery. This entire cycle of steps is significantly important in the case of quality. And that's what we are looking at. The quest for software quality. And in this quest, obviously, we have to, the only way to go forward is to look at other mature disciplines, how they do it, reflect, and arrive at our own philosophy. So that is the kind of thinking that we are trying to put over here. So we take a case from hardware and embedded systems. This is something very close to many of us. We all at our homes do have routers to connect to internet. And this is, so you might, if you look at the routers and the specifications and descriptions, they would describe the kind of testing that they have gone through. So the mean time to failure, mean time between failures, 30 days. So that's what it reports. Mean time to repair, 12 hours. And then they talk about a percentage. So these reliability indices are all reported by hardware and embedded systems. And this measurement is the first important aspect to look at. Because if we have to control something, if we have to monitor something and take action on that, we have to really have a measurement practice. And that is what, when we are looking at cloud systems today, they have started their own availability metrics. They are reporting the availability metrics like Azure from Microsoft, Google Cloud, AWS, all are kind of providing their own availability metrics. That is interesting. But at the same time, it's important for us to understand and how much of failure is happening, and the life cycle angle. SLA aspect of it. How much of failure is allowed in our system is something that we have to look at, because we probably build our systems on top of what they have as cloud services or the services they provide. So we also have, they only take care of their availability cases, whereas we have to look at the other layers on top of the system which we have to consider. But the measuring of availability and reliability indices very clearly indicate that we are moving towards a more higher reliability goal and not just availability. So that's the kind of thinking that we have to set looking at. And then another side of the world is talking about learning from civil engineering. The Golden Gate Bridge, that is what is shown here from San Francisco. This one, basically, the Standish Group report talks about it, that it has a full-time job for 30 painters and mechanics. And this is a very important part to understand, to maintain it, this structure. They are having a full team, continuously paints to preserve its glow keeping. So similar is the case with mission critical software applications. So it's not an easy job, obviously, to have maintaining the software system and making it sustainable. And that is where we are kind of going. It's more like how the bridges or continuous software engineering is moving into, it's taking us towards a flow. And then we should be able to survive failure conditions and continuously evolve. So technical depths are very important here. Like even the painting, they are talking about it. Probably they are not just painting just because of it needs to look aesthetic. They are also probably because the corrosive conditions as well matter of fact. So obviously this is the principles that we are learning from other disciplines. But we know still software testing is different. Software is different. So that is obviously the case that we are talking about here. How is software different? This is specifically talked about a lot in by Musa et al. In his famous book, Software Reliability. And the first bathtub curve stands for hardware, because if the failure is increasing over time, because there is a wear out, physical objects all wear out, and over a period of time it starts failing more frequently, and towards there's an end of life. But whereas when we look at software, since it is not physical, the failure rates kind of stabilizes after a certain period. And if you do upgrades, or rather changes, you can say, at that time, the failure rates increase. And if you really take care of the technical debt as well as bugs, and then control it, then it again stabilizes. So this is interesting aspect of software which most people are going to take advantage of, because it can evolve. But like we mentioned already, it's not easy. So that's the kind of continuous software engineering we are talking about. And that's where I have presented it in the form of a kind of a treadmill. But again, there is obviously when you are seeing this treadmill, we might be thinking, oh, okay, we have to continuously run at high speed. That's not the goal. It's more about consistency. And we have to really understand, we have to embrace this thinking that we are going to add more value to our customers. So that's where operations, when coming closer to us, we are at advantage because no more software is staying like an onlooker. Instead, we are trying to immediately act if there are problems, immediately act and take action, and results are seen. So here also you will see continuous integration and deployment playing a very big role, and data is kind of there is a lot of data flowing across the system. One of the example is we are looking at from a software engineering standpoint, those features which people are less using. We may not really want to add more features to more aspects to it, or spend more time on it. So those are the kind of data that is advantageous for the end user as well, because end user as well gets more focus on where they are really using the system. And that's where the dashboard kind of thinking plays a very important role. We also really like how a control system today, a plant is running. We would really need software as to be controlled from, and the dashboards which make sense of the data and help us take actions in the right time. So that is important. Discovery, reliability, evolutionary aspects come into play, but we are on this path. So I just want to pause here and are you with me? So I think we have come to a point of how significant software is and how the testing aspects are different and how quality plays a very big role. I hope most of you are with me on this. Sorry, I think got muted. Sorry. I think the continuous integration standpoint that we are planning here, kind of seeing over here as a kind of treadmill, means to say a lot. And that's what we are going to look at it as in the next steps, how we will do a good job in this continuous world and evolutionary world, the philosophy that we are looking at. So this is a combined philosophy slide which talks about how software engineering, architecture and design also looks at it, and also how tests will evolve. So this is the philosophy is today more we are looking at scale, because maybe like I mentioned, many of the SaaS systems are kind of giving an indication that, okay, we probably has an advantage with scaling. So if you have designed the system well and good, I can add more, more virtual servers to it, more virtual resources to it. On the cloud, I can provision more resources and then get it to more customers. So that's a kind of, thinking that is taking a lead. But this is evolving in the case of more reliable systems. So I would say that when we are talking about more trustworthy, high safety systems, it is still a little bit slow, like the scale, and we have to really balance the scale with respect to the performance and the latency, deterministic considerations there. But this is what they mentioned to the radio plane pilots, it seems. It's called keep your planes 2 mistakes high. So this is the thinking that we are trying to say. at least you should be able to, if two mistakes happen, still you should be able to fly or recover from that failure. So that's the kind of thinking that we are talking about here as a philosophy. Also with respect to testing and development. So built-in quality is it's becoming our major goal, because that is something we can look at it, because software, one of the major aspect is even though design may exist, if you look at hardware or electronics, the design might be there, and then from the design what comes out is most probably mostly 100% aligned to the design. But whereas in software, it's humans who are developing it, and there is always a chance that there is a drift from the design, and finally the software, the source code is the final design. So that becomes very important. So this built-in quality is significantly more and more important. We have to look at it from code quality, continuously look at regression tests, and look at integration interface tests, and this kind of reviews. So it should become part and parcel to everything that we do, and it should go give an indication in our dashboard. So that's one part of the story. Another aspect is it should always consider failure, because we are now realizing the fact that we don't have it as reliable as we think. So first thing is, okay, we have some kind of tolerance. So at least understand that tolerance, react to it. So then you consider some failure is going to happen, but within a short while, if you can, like a spring, recoil yourself, come back to life, that's something that helps our customer expectations. And consider scaling, because most of everybody, mostly this is a startup approach. When we say, okay, we start something very small, then put it on the cloud, okay, we'll continuously scale it. But it's not as easy as we think, but obviously this is the approach that is mentioned in the lean methodologies and the lean startup approach, and makes sense for the end user as well as executives, because we are not pumping too much of money, and as it evolves, it continues. So, but then we have to put the kind of, like I was pointing, the control system, the controls around it, the measurements around it, wrap it up so that we can clearly see how we are scaling and take actions. So that if design needs to make modifications, act fast to contain risk early on, because that is something as well important, because many cases it's not about some failure has happened. It's about how fast we can recover. Mostly it's mentioned before the next day. I mean, minimum before the next day, kind of, so that outage is taken care within. But obviously the Toyota kind of systems are looking at it from as early as possible, kind of an approach. And then we need to augment this with human and machine capabilities. So the response being predictable, and because if say, a failure happens, it should not be a firefight, rather. We should have a clear procedure approach to how we are going to handle that, and how our team is organized to handle that. That plays a very important role. That's where the human and machine capabilities both are complementary in nature. And here we are really looking at people playing a significant role in explorative testing and experimentation, where imagination, reflection, and innovation is going to be more significant. Whereas automate as much as possible the rest of it. So that's a kind of balance that we have to make and evolve, so that we can be more predictable. And there is another angle which chaos engineering brings into the whole thought process. It is about because if you are a commander force, you are not going to wait for that D-Day. Instead, you will continuously have your own simulations. You might run your own scenarios, and you might have similar attacks being carried out. Just mock drills or much more serious activity, so that you can be in that situation and you can play a good role there. There is again the star performance of your team as well comes out. So similarly, the same thing applies with software engineering here. It's a exercise also to learn and share. And then like Russ Miles in his famous book talks about there is a Bob or there is somebody in your team who is central and who everybody looks forward to when there is a firefighting. And it's also a thinking to have, it's to appreciate the member, also to fact that the knowledge should become more democratic, and other people also should understand it and take action. At the same time, it's also for maybe when you are doing these games, Bob should be not with the team. You should be sitting and monitoring the activity like an observer, so that he can come in and help as it continues, while the other team members get to learn the strategy. So this is the kind of philosophy that we are talking about. And so when we look at it, if we have to, so I think there was a question about testing, whether it can be pursued, whether it can be seen. Novice can do it with the help of AI. Obviously, you need the domain knowledge, without which you cannot, so it's not about a novice, it is obviously the modeling the domain in the fashion so that you can create the scenarios and test cases. So that's the kind of thinking that so here we are looking at more and more failures in distributed systems, because that's the kind of predominant systems that we are seeing. This is one example. So here, like you see here, the space shuttle case from NASA, this is similar, I think, with ISRO and most of systems engineering companies kind of handle it similarly. Like they had 5 nodes, and 4 nodes were part of one set of the system, and 5th node was separate. And the space shuttle could fly with 3 computers on and land with 2. If some failures happen, it had considered it. And then you see the 4 nodes were having the same input, same software, and same results expected, and they were comparing the results and voting based on which actions were taken. If the 4 disagree, the 5th one would take over and could perform some calculations with simpler software. So you see here, the 5th one is unique. It has its own separate software, which is not the same. So that this is the kind of redundancy we are talking when we are talking about handling failures. And this is the same thing which we will reflect when we have a cloud node as well. But the point is, it is more virtual in nature, and the aspects under consideration. Poor availability, there are several causes. So this, if we understand the causes of failure, we can build better test cases, and we can, with the understanding of requirements and everything, we can do better. So we are moving to an anticipatory mode of testing, where we are talking about early understanding of the system. So here we are just categorizing different application types into systems testing, software testing, and SaaS testing, and kind of going into each of these much more elaborately. So I will go into system testing. Possibly many of us have it very close to the heart. Here, reliability is very important. This is kind of aligned to the router world, embedded systems world. Hardware availability plays because early phases you may not have hardware available, because hardware is also getting developed. And then the approaches like co-design, where you can create a kind of simulator or something close to and provide an interface to your system. Then you can do a similar, so you can still work out the using co-design. Or this is an example from MATLAB, where they talk about entirely simulation starting point, rapid simulation, rapid prototyping, and then moving to software in loop, then processor in loop, hardware in loop. So this is the kind of, so eventually bringing in, so modeling and simulation is playing a very big role, and eventually the model-based systems engineering is playing a very important role in this system. And I would like to add here, even for us, we had to look at this was concept we developed, so that our human machine interface was still in the evolution. So we developed something so that we could integrate and still verify, look at our product manager could be convinced what is happening in the system. And Linux is playing a very significant roles in this research kind of environment, the dynamics and research, because it has the POSIX interfaces, and most of these systems, they also have near real-time capabilities. So I think this Linux capability is playing a very significant role, and the systems testing. Like one of the points I would like to stress here is with customer, we do also factory acceptance, site acceptance, and certification kind of tests in the systems. And this is predominantly earlier. The software sales kind of thinking. So now when we are talking about cloud-related aspects also, this kind of acceptance areas are coming into the picture. So similarly, when we go to, I just moved to SaaS testing because that is probably something area which is slowly influencing every other area. Here the SaaS scale is important, like I pointed out, the security aspects play a predominant role because you really don't know how much secure your system is. And then we are also talking about moving from availability to resilience. So that is, we are on the path to reliability, higher reliability. So the different test scenarios obviously increase more and more, and the scenarios and how do we really say the coverage is achieved. So cloud itself is a lifestyle change, like I mentioned. It's a continuous nature of systems that we are talking about. So resilience and recovery playing a very big role, and that's where we have to verify our systems. Some of the examples, the most we show here is in this direction. Software testing, I think this is aligned to what we just discussed, but here mostly the case will be like how can I migrate it to cloud? Many cases, lift and shift approaches to cloud, and then kind of cybersecurity guidelines like OWASP playing a role. And here still availability is still the most important characteristic. So here I think we have to step back and look at how we are organizing these systems in alignment to these changes. So one of the suggestions of how we could organize ourselves, because there is so much to do. How do we really do it? So we have to organize our system or the product into layers. That's what Jan Bosch pointed out in his 3-layer product model. So one of the layer we are talking about commoditized functionality layer, commodities, the platform kind of aspect, which is base functionality, and then differentiating functionality and innovation functionality. So actually, like you see here, most of our systems are moving in the direction of having common aspects, and then differentiating, and then innovation or experimentation aspect. So this is where we kind of try to attack. When we are testing, we really look at these interfaces are the starting points where we are talking about this interface, because evolution has to be also verified in addition to other aspects. So when we are verifying these interfaces, we make sure we are able to contain the evolution as well as the scenarios. And again, even the people and teams can be organized in this direction of 3-layer product model. So that's the kind of approach that we are seeing in terms of organizing. And then maybe we look at how we tackle this kind of continuous feedback. So speed is something many people are talking about. I need speed. But that's obviously, as human beings, we are affected. We feel, okay, I am under continuous pressure. So instead, I think the right way to look at it is we have to look at it from a consistency perspective, velocity angle. That average velocity is what we are looking at, not the top speed. So this is an example. So if you are a runner, you can obviously relate to it. When I talk about speed, mean your maximal velocity, your top speed. Even the world-class sprinters can sustain no more than 30 to 40 meters. So you see, this is about sprinting. So the world is not about sprinting. It's kind of consistency. Obviously, you have to take your turns and make directions, but it is more about consistency. That's the point we would like to make. Even in this diagram, we are talking about iterations. If iterations are there, again, we have to probably pause in between and do a little bit more detailed validation in between 2 or 3 iterations, because otherwise the number of bugs go up beyond control, and then we cannot come back to the earlier phase. So this is like we earlier discussed, we can take we can either struggle with all the packages around, or say we can make it automated, and then go to this kind of a position, like how the right image is about, how he's enjoying, he's able to enjoy, and he's able to pursue the kind of treadmill without much of suffocation. So that's the way to go, combining the human and machine capabilities to the best of it. So that is fast feedback is our objective, and early feedback. So we have to integrate tests in the direction of like I pointed out, each of these tests would require certain level of importance, and with those we should have the right kind of coverage of automated manual. And you see, manual is where we are talking about showcases, usability, and exploratory tests. So we are in this phase, we are looking forward towards building quality, and that's where the tools really come to help. So when we pass on to testing and integration, the typical landscape looks like you have some integration tests, interface tests, acceptance tests, and they are arranged like a pipeline, because that's the kind of flow that we are talking about. And then integration, execution. So, and then you have, most of the organizations do have some kind of development environment, staging, and production. And overall, everything availability is looked up from Prometheus or similar kind of tools for observability, and we have to have a dashboard. And these are the kind of tools which we see predominantly in the ecosystem: Selenium, Postman for API testing, build and integration, Docker-based API testing, load test, Locust or JMeter, penetration testing, Portsiger, Wireshark. So this is a typical landscape. So opportunities that we see over here is more like quality opportunities. We really want to have a closer loop between requirements design and testing, because this is kind of, if we make it more or less dependent on each other, we are never going to achieve the kind of agility that we are expecting. And this has to be tuned with respect to test-driven development. So we should have, we should really look forward to unit tests, interface tests, integration tests, and even acceptance tests. And some of these can be automated. Maybe it will start with exploratory by people doing it and eventually moving to automation. So that's a typical approach being followed in many places. So that being said, the design understanding helps the testing teams as well as the requirements. And we should more probably look at generation algorithms to generate test cases. That is where we will be presenting EvoMaster, one example. Pareto analysis, so that we could find out the 20% of test cases which gives the 80% results, the critical ones. Tools like Allpairs helps in some form. And we should also look at, today we are looking at InfoQ. I have an article which talks about predicting what test cases might fail. So put focus there, or Git analysis, like from the Git, where the code churns are, focus there more. So these are the kind of scenarios that we are talking about, using the opportunities, trying to leverage the data that we are talking about as a team and get it operating. The other aspect is probably more closer to one developer and one tester, which is the test debug cycle, which is more easily actionable. I think that is about the whole cycle is about detection, identification, and recovery. And like you see here, between test and debugging, obviously the knowledge has to be passed on, and possibly this testing and debugging should happen in a very collaborated fashion. This leads to test debug cycle reduction, which can lead to our mean time to repair. So this is the kind of thinking that we should have, more collaborative approach, and the learnings from these should be captured in some kind of fault tree or Excel sheets, maybe which will translate into machine learning models as well. The other aspect which we see predominantly, which is helping us, is the chaos engineering thinking, like the gaming aspect of it. The commando is more interested in always trying to recreate the scenario. So here we create the outage that never happened. So that is a kind of, and we hypothesize that some failure is going to happen. So we explore, we discover, we run some kind of chaos tests, experiments, and based on the experiments, we try to discover some weaknesses, and then analyze and improve our system. So that is obviously, this is most importantly done with the team in mind, and this game days kind of an approach is very important part of the story. So this is the most embracing chaos is the way to go. So I think just to touch upon, maybe we are close to the time. So I'll just speed up a bit. Testing of AML use cases is becoming more and more significant features, and the data itself needs to be validated on one side. At the same time, when it gets deployment, the performance needs to be valid, and in between the models have to be as well. So the humans, we have to really put a lot of review points here, and more probably have a kind of W-like approach where we verification of V is complemented with the data as another V to be verified. So that's the kind of approach which is mentioned. And we probably need to run pre-trained tests and post-trained tests, because sometimes data can lead to problems. So we might need to have some kind of well-defined test, and then something which can go deviate from our direction. So that is important part of the story. So one example for RESTful API testing, which gives us a flavor of how it's evolving, testing is evolving, is Ego Master. So this is a GitHub repo, and it can generate test cases given the open API specification. So it's of huge value. It's an open source tool, and many of such similar tools are available, but they are probably proprietary. So the generation of test cases helps a lot. We can evolve these test cases, and more and more it uses an approach. These are possibly research areas where people could focus time on how generation can be done, and similar aspects of so that testing and how we could still enable, and the smartness of testing as well. Chaos engineering, I would like to leave you with a demo of chaos engineering toolkit, even though time is short. Like it talks about a steady state hypothesis executing method, and then deviations capture. So this chaos toolkit is link. I have shared it, and details are like this. This is the experiment that I have defined. I have two applications running on my machine. One is a backend, one is a front end, and then I also have a Redis database end. And then when I run the test, it will shut down. It can kill my Redis Redis node, and then we can see how it operates. So that's the kind of scenario that we are talking about with chaos experiment. We can do a lot more with chaos, but then I am just going to share. I hope you are able to see my demo screen as well.
Yes, sir.
Thank you. So I think, thanks. So here I am running the chaos experiment that I have defined. So you see here, it's leading to checking the steady state hypothesis. Then it is going to a method called, which leads to kill. It will simulate failure. And then again, you will notice since I am running Docker swarms, it will recreate that node. So this is the kind of recovery that we are talking about in this scenario. So you see the steady state experiment still successful. There is nothing to, so a lot of significant experiments and exploratory work can be performed on this platform. So that is kind of highlighting it. And I also shared all the links so that you can pursue it. So the key takeaways for software quality at the site speed is about weaving requirements. This is probably, obviously, it is a lot of work, but then there is no, other way. The test-driven kind of approach, built-in quality kind of approach playing the big role. Reducing time to test debug cycle, which is something everybody of us can do, and use data to build fault models. This is including ML and data, and taking advantage of it to create better user experiences together with test focus. Embrace chaos principles to explore and experiment, take advantage of the human part of it, and get to the next level. So this is the path to world class that we foresee that testing can be pursuing. So that is where I would like to leave you with this thought process of world class, which what Guru Kalam says about is all birds find shelter during rain, but eagle avoids rain by flying above clouds. So this is the kind of spirit that Skyroot Aerospace also projected when they sent Vikram S to space, the highest, one of our great visionaries. And we have also Sridhar Vembu's colleagues talking about products that work together, and Sudhanshu Mani with Vande Bharat Express from the Chennai Integral Coach Factory. So I think we don't have any more excuses. Let staying world class be our goal. Thank you very much for your time and attention. I'm ready for questions.
Sir, thank you very much for your wonderful presentation, sir. Now I will read out the questions one by one received from the registered participants. So what are the upcoming challenges and opportunities for software engineers?
When we are talking about the continuous engineering mindset is what we are really looking forward here. So software engineer. So one of the main perspectives, I say, an individual software engineer can play a big role looking at test cases himself or herself and trying to contribute in the testing as well, and then playing a role in the test debug cycle, which is very important for the recovery aspect of things. So I think while as we go senior, you have more influence, we can play a role in other aspects as well. This is one thing which I feel is significantly important. And again, if you have a machine learning intensive interest, you can also do a lot more analysis and pursue it, like fishbone diagrams and things like that were the matter of the past. But here we are looking at visuals, visually taking action. So I think that is another aspect of how we are moving forward. The proactive initiative, it's all about leadership to a certain extent that we are looking at. Thank you very much.
Thank you, sir. Next question. Can software testing be taken as field in PhD?
Software testing, obviously, many people are pursuing it as a PhD in the areas of test generation, for instance, or like program analysis is one which is being pursued a lot, I think, and testing adds significant practical value. So I think, and even smart ways to verify testing, and chaos engineering is also an emerging area which can also be pursued. So I think these are all areas of approach which can be pursued in research.
Okay, sir. Next question. Can software testing done by layman assisted by artificial intelligence?
Like I mentioned, to define the test cases, you really require somebody with a domain background. I think, like Nandakumar has mentioned, quality requirements have to be specified. Many of the software projects don't have it. That's a challenge mostly architects have. So I think these requirements, once you have to translate it into test case, and maybe execution, but execution doesn't require a person. You see, it can be fully automated. So why you really want to put a person and later he or she loses her job because it's just an automated part of it. It can be automated. So I think it is more about adding value to the human aspect of what we should pursue.
Thank you, sir. Next question is, what is the future of human involvement in software testing?
Yeah, I think in his book, a famous book, Don Norman talks about what makes us smart. So it's about the capability to imagine, innovate, reflect, and improve. So that I think that is where we are talking software testing. People also should more focus on explorative testing and then try to automate everything else. So many people in the software testing area, I have noticed they are afraid of testing. They think Python is something you cannot learn, but rather I think if you are open to learning, Python is probably an easy language to learn, and we should also understand automated testing so that we can pursue it and support the course. And then we should move on to higher levels where we could contribute to the product, because I am seeing a huge opportunity for software test engineers to contribute in customer experiences, which is more important as we go.
Thank you, sir. Next question. What are all the challenges in testing AI/ML software?
I think we addressed partially part of it. One of the major challenges here is we don't have a defined ground truth. For the defined input, we may not get the defined output. So that is the kind of challenge that we are pursuing here. But that's where, again, pre-train test we are talking about and post-train, because what happens is your logic doesn't get tested. So logic has to be tested from a software perspective, and then you integrate ML aspect and then verify it again. Kind of. So that's where we are. Spice and everything is talking about verification of software independently, and then verification of data so that it becomes integrated. Because otherwise, you may not be able to figure out where things are going wrong. So these are challenges. And again, how much of data set you have, what is the kind of data sets on which you are testing. So these are all new challenges with respect to AI and ML. But we are right now more looking at explainable use cases there. So I think we are now looking at reasoning to be part of the systems to encourage more of those tests and see whether are we going in the right path. So I think it's still an emerging area of work, but it is ongoing, and we really require a lot of tools in that space to support the ecosystem.
Thank you, sir. Next question. What are all the testing tools that can be used for automated software testing?
I think we discussed, I think like EvoMaster, we have a lot of, say, Parasoft, we have a lot of similar tools available in the market, which can be integrated, which provide a full test suite. And then scripting tools which allow, so each of the different, say, UI testing requires a different set of things. UI testing requires, and then API testing requires another set of things. So this is kind of a little bit varied ecosystem. So what we see is a combination of some tools might be proprietary, some tools like Postman, and if you are using in big numbers, obviously we have to get the licenses, and all like API testing is predominantly important. Selenium, open source. So it's what we see is a mix of open source and other proprietary tools are getting integrated. But the primary objective is all these should feed data to our dashboard so that we can understand what is happening in the system. That is primary, because without that kind of information, we are probably, because so much of things, activity is happening in the continuous system, which we may not be able to comprehend. So this is the kind of, so it should all be kind of integrated into one visualization aspect so that we can take proper actions.
Thank you, sir. These are all some of the questions we have received from participants. Now, I invite Mr. T.V. Kamalakkannan, Chairman, Computer Society of India, Chennai chapter, to propose a formal vote of thanks. Kamalakkannan, sir?
Yes. Yes, I'm here. Maybe I will request Dr. Akila to present vote of thanks on my behalf.
Yes, sir.
And but before she starts, thank you very much, Mr. Abhilash. That was a wonderful presentation. But we'll request Dr. Akila to propose formal vote of thanks. Thank you.
Good evening to one and all. Thank you, sir.
Sir, good evening.
It's my immense pleasure to propose the vote of thanks. It was a very nice session. You started with some significance of software engineering, and you just told what is the importance of software testing and what are all its metrics and all those things. It was very nice session, sir. Thank you for giving us nice exploration. And I thank all the eminent personalities over here and the persons from all societies, IEEE, CS, ACM and CSI Chennai chapter for your esteemed presence. I thank all the participants for participating and asking very effective questions. And thank you, especially thank Abhilash sir for the Q&A session. Thank you, sir.
So I will share the slides. Thank you.
Hello, sir. Sir, good evening, sir. Sir, the section was very informative and very interesting. And I would like to ask you a question. Like, can you tell me what testing tools are used for automated testing of software?
Yeah, I think I just shared some of those examples in the session. So I will just re-show that slide. for your benefit. So like each of these scenarios require a certain set of tests. Like Selenium is predominantly used with web UI testing, and it is a framework and it's open source. API testing, you use Postman or Rust Assured or similar kind of tools. So there are obviously there are a lot of alternatives. Here I am presenting one alternate which is also open source, so that it is available, readily available. Build and test integration, we are looking at, that's where I was talking about integrating everything. And Docker based, this is again an extension of Postman. Load testing is done using Geminitor or Locust. Locust is seen as, and then major tool these days. And I think we also have a lot of proprietary tools, and we might require some of the high-end tools to do load testing if you are looking at scaling. Penetration, like the cybersecurity test, Burp Suite is used, and it is something that we have in our experience. We have seen it working very well. So network data analysis, Wireshark. So it's a combination of the several tools that we see as a kind of suite. And some of these, like Parasoft is one example. Similarly, there are several toolkits, tool suites which are available. So some of these are based on our own experiences in the platform development, and there we could really make a significant platform, and I'm really proud of that activity that our colleagues have done. So so this is a summary, but I think I also introduce you to some of the latest tools like the Chaos engineering tool and the UO Master was just generation tools. So those are the areas where it's still emerging, and testing AML use cases is leading to more and more kind of tool requirements, because how to accept and create some acceptance test cases there is becoming more and more significant. I hope that the ecosystem is huge. I can only give you some examples, and more probably the ones which I am more comfortable with. Okay, thank you.
Okay, thank you, sir. And sir, can you please tell me?
Let me just add a few. Sorry, Dr. Shakti. Mr. Mishra, sorry, go ahead. I thought you finished. Please go ahead, sir.
Sir, can you please tell me from where I can get some tutorials for this Evo Monster and Selenium and all that? So where can I get some good tutorials to learn about this Evo Monster, this chaos engineering, and all these automated software testing tools?
I think, yes, it's all, you go to YouTube, you will find very nice tutorials on all this material that I shared. Selenium, and I think on the Chaos Toolkit, I have shared those links which are most relevant. And so I think there is a lot of enough great material there, and also the book from Russ Miles, Learning Chaos Engineering is a great one. Yeah.
Okay, sir. And sir, I'm quite familiar with Postman because I have used it before for testing APIs through the Post and Get methods. So I'm quite familiar with Postman testing.
Thank you.
Okay, thank you, sir.
Thank you.
Sir, I'd like to add my word of thanks. This is a KK chairperson of CSI. I think you gave a fantastic treatment of the subject, as you started nicely with the testing, right? Testing is the most, I would say, sort of neglected in the sense that's a sacrifice we always make before delivery. I've been with the TCS for a long time, and of course we try to avoid that, but sometimes the client pressure and all of that comes in, and you sacrifice, you pay double the cost at the end. But people seem to go with that kind of approach. I mean, let's first deliver, then let's figure it out. But you nicely explained why testing is so important upfront, and how do we actually build the use cases, and you nicely covered chaos engineering, and also you touched upon the latest technologies. How do we develop the use cases for the latest technologies? So it was a wonderful presentation. So I'd like to add my personal thanks to what Dr. Akila said. Thank you very much for joining us in the weekend and sharing your knowledge.
Thank you very much.
Thank you, sir.
Thank you, Mr. Abhilash.
Thanks a lot. Thank you.
Thank you
Thank
for
you for
your-
giving this opportunity.
For your continued relationship with us.
Thank you, sir. Thank you.
Thank you. Have a nice weekend. Bye.
Thank you. Have a nice